Ladies, gentlemen, internet, and all other people. This is my first ever video of me trying to do this. I'm trying to make like a Leetcode video solution, random thing every day. Hopefully I can throw a little bit, some entertainment in you. So what are we doing here? This is a subtree of another tree problem. It's an easy problem. If you find it hard, don't worry. We all got to start somewhere. So you're reading this problem, and basically what you're doing is you're given two trees, and you're trying to see if one of these trees is a subtree of the larger tree. And it's not necessarily larger, but you're just trying to see, all right, you have one tree. Is it possible that there's an exact replica of your one tree in this other tree? That's essentially what you're doing. Now, there's a couple of ways of doing this. There's a smart way, and then there's like kind of a more intuitive way. Let's code up the more intuitive way, which is basically you would create a depth first search, meaning you're going down, 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 and it could be like you're searching the search tree. It doesn't have to be depth first necessarily. It could be breadth first, but you're going down and you're searching the tree, and you're looking for when this node equals this. So you would create a target, and you would look for your target in this tree, and then maybe you would have another function that replicates, that searches both these and makes sure they're the same. That's the ugly way. I might do this in an ugly fashion. I think there's like probably better ways than where I'm going to do it, but this is what's just flowing from my fingertips. I did this problem like 2 days ago, so forgive me. And I have sort of my own style, which is needs to be revised because it's not the most ideal. But first, let's create a target because that's what we're doing. We're going to do subroot val equals our target. And then what are we going to do is we want a searching DFS. We'll call it, I don't like these long title names because I have to retype them, but whatever. Searching DFS. And this simply just looks for our target. So this will return if r is equal to none. So if r is like a none node, then it just branches off, it cuts this off. I might want to turn false. See, this is where it gets a little tricky. This is like, this is like an easier medium one. It's getting closer to medium. There's a couple of things you got to juggle if you have two DFS search functions in here. Because when you call your other search function, it's got to have to return a true or false. That's the point of this, is returning true or false. So what do we do here now? So if so now we're trying to see if our val is equal to target, then we do our search. And we'd probably want to return the result of that. And then let's see here. We're going to call this again because we're going to do this, but we're doing left node. And so it's going to keep going down, left, left, left. So DFS is going to go, in this case, we go 3, and then we do another left node 4, then 1. So, but if this is true, we're going to return true. So what are we doing here? I have to think about this. I don't know if this will need the return false. Alright, so we create that function. Now we got to do our actual comparison. So this is the function that now gets called when we do reach our targets. And this one is going to take two things. We'll just call it checker. And this is to check if it's the same. So we're going to do, just not to confuse Python, we're going to do double R is our original, and then this is our, we'll call it sub. And then if R not equal to subval, because if they're not equal, then, but first we also want to check, I don't know if I should do this in multiple lines. I might actually, just for clarity's sake, for the internet's sake, we want to do if and then we do the reverse. So we're seeing if you get a none value on any of them, then they're obviously not the same trees. So let's see, this equal, ooh, crazy mouse on my different computer, a Linux system. I usually don't run on a Linux system, but I gotta practice that bash command. So now we're checking different values, different trees, if like we reach the end, if they're not, and then we go, so this is DFS, we're going checker here, and we're just going down the same tree here, and we're getting it. So if this returns true, and we want this in the same line as this too, and here, and this video presupposes that you understand how a DFS or traversing a binary tree works. Sorry, I'm not going to explain it. I should though. I will in another one, because if I can't explain it perfectly to you, then I probably don't know it. That's the point of these videos. Sweet. I don't know if this is all perfect. I think there's like some details I'm not thinking through properly. And good practice is to not run it and try your best to catch the errors. Like obviously I forgot to leave this commented out, so this is going to be on line 22. Uncomment this out, and I called this checker, and there's this cool little thing called non-local on Python 3, and we're going to do it subroot, and we're going to do our subroot, and non-local just gets this global calling. It's kind of like a JavaScript-y type thing. Get that capitalization right. Now let's think about this before we return this. DFS, if this is true, return true. true, else false. Let's see, return false, return. This is if target is return. So if it calls this and this is true, it will return true eventually. Else, I should just do, I could do an elif here, but none of that matters. And this doesn't matter too much. Alright, and what am I not thinking about? What's the edge case? You gotta think about edge cases with this stuff. I think what I'm not thinking about are two things. One, if target is, we hit val, it checks it. I think actually what we want, if this is true, return true. Why did I do this? Because if the root val is, say if root has a 4 here and a 4 here, then it will check here first and realize, oh wait, these aren't the same. But if it goes down the way I changed it, it will still search this one. If I didn't search it, it would just return this statement, and we don't want that. So what's my logic in here? If the val is not equal, oh no, we don't want that. Our val, no. Yeah, that's all bad. That's called copy and pasting and not thinking what you're doing. So this is just check if any of the nodes are none. This checks if the values are not equal, and that's what we need. And then this checker needs both these to be true. And we're going down left, then right. Correct. Else, return false. Yeah. Okay. And then we search DFS R. If R is equal to none, return false. So if we hit the bottom, I think this is good. Let me just read this. Target, we made target up there. And if R, I don't know, I actually am not remembering, but this may not like Python may not like this. It may have to be like we put target in a dictionary. This will be a good test. Hopefully I learned something from this. And search left, search right. This is our checker, our subroot, variable names, our sub. Alright, bonus points if you see an error that I don't. R is not defined. Uh-oh. This is what I'm talking about. I would have failed the interview. On line 29. Damn me. Damn me again. Runtime has no attribute val. Or I made a mistake, ladies and gentlemen. You have to also check if they're both none. Dude, I love these ThinkPads. Great computers. Alright, well, let's run this. Hold your breath. Oh, I did it. Slightly worse term. Alright, so I hope that makes sense. What is the runtime of this? Your runtime technically will be like n times 3. Sorry, not n times 3. It'll be your how many nodes are in this times how many nodes are in this. Because what are we doing? Well, we're going through all these nodes, and this is worst case, and then we have to check, like imagine our tree, let's go back to this thing. It was really long, and we check, and the last place is like right here to check. So worst case is we're going to do all these, And then we're going to go do both of these at the same time. Actually, to be honest, I think worst case is nodes times. Actually, I have to get back to that. I believe the answer is that worst case is all these nodes. Then it's all these nodes. I think so. So it'd be like CS times T. S would be all these nodes times this. I don't know why actually now I'm saying that out loud. Because I'm like, wait, this would go through all these nodes. And then say it has to go through this. It would still just only be these nodes. I'll have to look into this internet. I'll have to look into this. Alright, anyway, so let's try to do the next one. So the next one is we're going to do this but with a hashing function. And the hashing function is going to be, this is pretty tricky. This is, I saw this on kind of some other people's solutions. I want to try to implement this. This is using basically a Merkle tree. In a Merkle tree, what we're doing is we're creating a hash for each node, and then its parent uses the hash of its children to create its own hash. And that is an incredibly unique one. So we're going to use SHA-256, which actually is not the most ideal hashing function, because you could use other hashes that are not computationally so heavy, but here we go. So what we're going to try to do, actually I've not implemented this, so internet, bear with me here, this could get messy. We'll call it hash. Terrible naming convention. I feel like more pro would be like this, and then that would be more pro. Let's do that. Hash, then we're passing in its hash, we're creating a hash function, and then we're using the SHA-256, what we just imported up there. Fuck yeah. We're getting it, internet. So this is our what we're going to return back. Call it res for result, and then we're going to pass it a update, which is that's what updates it, and the update is going to be this. So we're creating a random hash. It's very random, and then we're adding in, we're updating the hash to take into account of our previous hash. So let's see here. I think what we're going to want to do is, you shouldn't have this on, but I did. I don't actually have it on my other computer. Or auto suggest. That means I don't know. In an interview, you're going to get freaking fried that way. So this way, you've just created your hash. Now you got to create two functions here. Again, we're going to do in two functions. One's going to be the Merkle function, and then we're going to create another one that's just a simple DFS. And our simple DFS is going to let's see here. Our simple DFS is going to simply just check for if our Merkle hash for our subroot is equal to any of these. So what do we do here? If return none, yes. So we branch off, we end this. Merkle is going to, what are we going to do? We're going to Merkle R left. Merkle R not equals none. Do R left. Ooh, I don't actually like this. There we go. So we're getting a hash back from Merkle. We're using our hashing function. And we're going to create a new value, which is here we go. Here we go. Look at this, kids. We got it. We got it. So now that it has its hash value, and then it needs to return our hash value. Alright, this is looking promising to me. And then we're going to do Merkle root, Merkle subroot, but we want this one. Again, we're creating a target. Now I think about this, thinking about this, I'm like, oh yeah, you have to make a Merkle. I feel like we could actually make this into one thing, where we could, I'm going to talk about it later, but anyway, it's not clean code, but we could clean this up. And then we do a DFS, where DFS just goes down root. Let's see here. None. Yeah, same pattern here. Return none. It's hash value. Oops, going wild. Goes target. And then do same pattern. But here we could probably throw this in one statement if, let's see, R left or DFS, DFS, R right, return, return true. Else return false. And then we do DFS R, and I was about to make the same mistake I made last time. So what do you guys think? Let's just double check this. We're creating the hash. I don't know if this is 1000% correct. And that's just our hashing function. This is our Merkle function. Merkle like Urkel. The purple Urkel. And then we Merkle left, we Merkle right. Then we hash value of left to right. We return our value. We're going to create this. And then this just searches for our hash value. And we return false. Return DFS true. What else? What else? We could clean it up and make it less lines. Like, we can make this, I'm pretty sure, one line in itself. Pretty sure. Oh no, I don't think we want to do that. We don't want to do that. I take it back. This doesn't actually return anything. These just update res. This may actually return something. This does return a hex digit. And then this half delay, hash value. This is definitely, if you score this line over, you are aced the hole. You aced the hole. You're golden. You're, I would say Tiger Woods, but I don't think he's liked too much. Question this part, left to right. So I just looked at a solution. Apparently, I'm supposed to do this. Okay, let's run it. Invalid syntax in if line. What is this line? Turn 30. What did you not like? Duh. You know what? I think let's try this. I actually don't know. I just puttered. I just punted. Bummer. Feel like I got so close and yet so far away. Well, this is a good time to use the internet. Unicode objects must be encoded before for hashing. I'm not very familiar with this one. So let's see here. Oh, can't copy and paste it, right? They probably did something I did. They're using a different one. You think I should do this? I don't know. Goddamn internet. You're crazy. Let's try it. I kind of want to see this work. It's complaining about this, though. It's not complaining about this. You know what? Fuck this. I just saw the light. And not in a bad way. I don't think that'll work. I'll try this. Let's try that. Oh snap. Oh baby Jesus, we just did it, internet. We just did it. Now let's look at this. Let's just compare this. So this went through this entire tree. And then, see, the issue with this one is that what happens if your target is almost all of them? Then you would have to go check, and then it would be S times N. And then for this one, because you're creating unique hashings, your worst case can't be S and N. Alright, I'm going to create another video. This video sucked. I'm sorry, internet, but I'm doing it. I'm doing it. It's first one ever. Batter's up. Oh, how do I end this? Oh, there you go. Uh-oh, don't show this part of the video. Oh, God.